It is raining, but I do not believe that it is raining. This statement, an example of Moore's paradox, sounds absurd. And yet, this statement can be mathematically true, is logically consistent, and does not contain any logical contradictions. At first sight, this seems to be a paradox, but let's break down what this statement actually means. First, let's take a look at propositions. Propositions are statements that are true or false, but cannot always be determined as such. For example, all ravens are black and all apples are red are propositions. In addition, propositions can describe information dependent on my current position and time, like, it is raining right now. And even about the current speaker, like, my name is Sanguine Whale. Now, let's introduce the belief operator. The belief operator takes a proposition as input and returns whether or not the speaker believes it is true. For example, if we plug the statement, all apples are red, into this operator, it will return, I believe all apples are red. Note that the return statement is also a proposition in itself. Now that we have set up our definition, let us describe some axioms for our belief operator. First, we have consistency over negation. If we believe a proposition, we do not believe the negative. For example, if I believe it is not raining, then I do not believe it is raining. Or if I believe all apples are red, I do not believe not all apples are red. Second, we have consistency over conjunction. If I believe two propositions, I believe their conjunction. For example, if I believe all apples are red, and I believe all ravens are black, I believe the proposition, all apples are red and all ravens are black, to be true. Do note that consistency over disjunction follows from the two previous statements. And last, we have idempotency. I do believe all true propositions about my own beliefs. In other words, if I believe a proposition, I believe that proposition. For example, if I believe all apples are red, I believe all apples are red. Now that we have all our axioms out of the way, let's take a look at our original statement. It is raining, but I do not believe that it is raining. Mathematically, it denotes a conjunction, so we can rewrite this as follows. It is raining and I do not believe it is raining. This statement can be true if it is actually raining, but I wrongly believe it to not rain. For example, I might be inside with closed windows, and the absence of sound makes me erroneously think it is not raining. Now we can ask the question, can I believe my own statement? Is it possible for a person saying, it is raining, but I do not believe that it is raining, to believe their own words? For that, let's take a look at the statement, I believe the statement, it is raining, but I do not believe it is raining. This statement can be rewritten as, I believe it is raining and I believe that I do not believe it is raining. Using idempotence, this can be rewritten as, I believe it is raining and I do not believe it is raining, which is a contradiction. In conclusion, the reason the sentence, it is raining, but I do not believe that it is raining, sounds absurd, is not because it is impossible for the speaker to be correct, they might very well be. The problem is that it is impossible for the speaker to believe his own words. It is impossible for him to think he is speaking the truth, independent of the truth of the actual statement. If you liked this video and want me to make more similar videos, please leave a like and subscribe.